Hello everyone. This is a little project I've done using. I've got two DC motors turning these little gears here. Basically, I've got a rack and pinion. I'll take one of these off shortly, just to show you what it is. I've done a drawing as well, so I can show you the drawing I've done. I've just got a servo for lifting the pen up and down. My little Arduino down here. Basically, all we have is the pin to the servo. I've just got the three wires. Well, there we go. I've just got three wires, which is ground, VCC, and the signal. So I'm just using pin 10 of the Arduino there, and then I've got this other wire, which is just the I2C, which is VCC and ground, and the clock and data lines. And the VCC goes, hang on, let's just see if I can get that in shot. The VCC goes to this socket here, and this is what's powering the VCC side. And then I've got here, where are we? This is the power. I've got 20 volts coming in on the power. That's the power for the motors. And I'm using my little Dual I2C Motor Driver. So it's got little two drivers on there. And basically what this does is it takes the quadratic signal from these two sensors to determine its position. It's pretty coarse because the encoders are directly onto the. This is what the encoder looks like, and I've only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've miscount. 1, 2, 3, 4, 5, 6. I've only got 12 slots in there, 12 shutters, and basically that's here on the end of the motor drive, which is basically getting turned as the rack turns. So basically, because I've only got 12 slots, I can we can get 4 states from each slot. So that's about 48 ticks per revolution, and it works out about 0.75 mil. I don't know if we can see the line, the circle it's just being drawn there. But the resolution, it's accurate, but the resolution is not very good. For positional accuracy, it's very accurate for its position, but its resolution, the line, it's a bit steppy, if sort of thing. It looks like a staircase. What I'll try and do is I'll try and get my little camera sort of to view the thing. But basically, what it was, it's more of a proof of concept really than anything else. Yeah, so here's my camera. Let's just have the camera. Let's just put that top right there, and let's see if we can see. And well, I'll get some focus. Let me just set it up. Set it up on something. I know it's going to change in a minute. That's the trouble. Give me a minute with this. Right. Let's see if I can. Right, there we go. So I can see that line. So can we see that line now? Yeah, there. We can see the line it's drawn. It's a bit zigzaggy. Whoop, can you focus? Yeah. You can see that it's. You can see the steps. So that's its resolution basically. But like I say, it was just a proof of concept to see if my motor driver could actually control two motors to actually plot something. Let's see if we can get the so you can see that circle. Let's see if we can get some colour, brightness. No, I think I had it best. I think I had it best the way I had it before. I think I just messed it all up now, haven't I? Yeah, I think. Right. Oh no, I've really messed it. Right, I think I'll leave it at that. So you can see the circle, and so now what it's doing is it's just drawing a diagonal line. I'll show you. So you can see at this end, where you can see it's the resolution. There we go. So it's basically that's actually going over a line exactly. So but when you get somewhere like here, you end up with like a curve because this arm is hardly moving. So you get to about here, it's just like a straight curve line. So yeah, I just wanted to show that working. And oops, I got it stuck. Yeah, I've got stuff. There's pros and cons to this. You need a lot more room because you need somewhere for all this to go as well. But yeah, it seems to be working all right. What it's going to do is just draw the other diagonal down this side, hopefully. Yeah, you can sort of see the circle there now, so I think the light's a bit better. And you can see the straight line going across. But like I say, the resolution of the line, because these my encoders, there's only so many ticks per millimeters, so you can see by this gear how far it's actually moving each tick. So these are my quadratic encoders, which I've made out of a couple of these. They had the hang on, let me get one that's complete. Yeah, this is a complete one. It's basically one of these modules you can buy on the internet. It has now I can't pronounce this. Let me just. I'm going to get a data sheet. I can't pronounce the name of that. Basically, what it is, it's an inverter, but it's one of them inverters that the output it goes totally to one side or the other side, depending on the voltage received from the thing. So what I did was I just took these two. I took the infrared receiver and transmitter off, added wires to them, and that way I could. I'll take one of these apart and show you. It's about finished there. So what I'm going to do is I'll just pause it and then I'll take one of these apart. Right, I'm just going to pause there. There we go. I've taken the arm off. You can see a bit better now the way it's drawn. I mean, it also plotted this line, but you can't hardly see it very well. You can see it a bit here, sort of thing, but it's spot on the line. But the resolution is I don't know if you can see that there. It's a bit. Anyways, here's one of the arms. So basically, I've just got this rack with my teeth. I've cut it all out of that hardboard stuff with the white finish on one side, and this is all made up of layers of it. So you know, I don't know if you can see that. I've just screwed layers together to make up this section, and it's got a geared motor on this side, and then at the end of the geared motor we've got the encoder with the gear on, which actually pulls the rack through, and as it rotates I've got two LEDs here, and well, so these are the actual LEDs which I've just extended from the ends of these, and then these are the two receivers. So basically when this goes across, well, I'll show the drawing of that, and I've got a stop here, so basically once this gets to the end as well, so if it all goes through around to the end, I've got my stop, and that also zeros everything using I've got the two wires coming into my motor driver. So this is these are the stations, which is the stop here, and then you've got your two motors, which has your VCC in the middle, then you've got your motor power, and then you've got your incoming from your encoders. Yeah, so that's that bit. Right, I'll just set up my drawing, just give me a moment. Yeah, right, so here's my drawing, my model of the thing I've done. So it pivots on these 2 points here, up here, there, and here, sort of thing. Well, they're the pins that hold it all in, but basically it pivots on them too. At this end, I've just got a servo. As this turns, so these two arms push this piece down through here to lower the pen, and then when it turns the other way up, these two arms lift that pen up, so it keeps it in the 2 positions. So that drops the pen, and then when we lift the pen up, I've just got this little leg here for it to sort of holds everything up and the pen out the way, so when the pen goes up, all this doesn't drop. And let's have a look at one of the racks. So if we look at the rack and pinion, this is what I've just shown you. So we've got, that's the, well, I call it the hinge. It's where the two meet together and the pen goes through that hole, and this is the pivot. And then what I have here is, like I say, I've got 2 of these little modules that you can buy on the internet, and originally these two, this LED was here and this LED was on the other side. So what I've done is this one is for these 2 LEDs. Well, there's a transmitter and a receiver, and this one is for that one. And what they do is so these receive and the ones below transmit, and what happens is we've got this encoder here. If I just make that invisible, you can see that it goes down to 2 slots here. So this is receiving light through these 2 slots. Let's just make that invisible. Oh, hang on, wrong thing, cancel that. Press the wrong button. Yeah, there. So it goes through there, and underneath there we can see that the encoder there and so they're the slots. So as these move round, it's going to let light through them slots there, and these are going to pick up receive. So I can show you a better picture of that. Let's just put that back and put that back. And where's the other one? There, that's that one. Oh shit, wrong button again. That one. There we go. So yeah, so as the motor rotates that, it moves this gear, the rack, backwards and forwards. So if we look at the gear, so what I've done is I've just put one plate here and the encoder. If I just remove that encoder for a moment, you can see the two slots. This is where the light passes through these slots. It's infrared light, so we can't actually see it. But if I bring back the encoder, and if I make that encoder sort of transparent, you can see the encoder. And what I can do is we can rotate, and I can show you how it creates. Oh, let me just pause a minute. I just want to calculate something. Yeah, there we go. I just wanted to calculate the angle. It's 7.5 degrees. So we've got 12 shutters. So if we divide 360 by 12 and then divide that by 4, we get 7.5. So that's going to, every 7.5 degrees, it's going to change the state of our quadratic encoder. So at the moment, you can see that the shutter is blocking light through both shutters. But if we move 7.5 degrees, you can see that that one shutter is now letting light through the one on the left. And then another sort of 7.5 degrees, we're letting light both through both. And then we move another, and we're only doing it on the right now. And then we go to, we're not letting any light through at all. So that's the 4 states. And depending on the sequence, so if it goes left both and then right, it means we're turning clockwise. But if it goes right, left, then we know we're going anti-clockwise. So that's how it determines its direction and how far it's moved. So I'll just pause it there. We'll look at some code. Okay, let's have a look at some code. As usual, I just I put a comment at the beginning, just giving us an idea what the code is about. It's written for the Arduino Nano, using the Arduino architecture. Oh, well, I've got the wrong one there. Yeah, here we go. Here's the right one. Using the Arduino architecture, I've also, we can use a library for the servo. There's servo libraries, but just for this bit of code, I just wrote, I altered the timer 1, just to give us a pulse width modulation. So it's using the AVR architecture. It's not pure Arduino, this code. It compiles, but it's only for the Mega, what is it, 328. It's for the chip that's on the Nano. It uses you've already seen the Dual Motor Driver. Actually, I've done I've done an instructable for my motor driver here. So basically, any I2s any microcontroller that has I2C, you just send a signal to it, and it can control two drivers. So there's your motor driver. Goes to my motor driver, and you got two motors. You got feedback both ways as well. So it was done by, had it made at PCBWay. If you go to my PCBWay projects place, you'll find all the details there to get it made. There's a version 2 now, so make sure you get the version 2. It needs programming. I use the ST-Link to program it, but basically that's it. You just connect ST-Link to these little 4 tabs and program it, and off you go. And I've shown you how to program it, and these are all the commands, but these are the commands sent through I2C. So we will see basically me using the global M1, and I'll be using this G goto command. So it's this command that I'm going to be using in the code. So yeah, come back to so you can get one there. So yeah, here's wires. Oh, here's a bit maths. I don't really need that there. Forget that. We don't really need it because we're using Arduino. Arduino already includes that. And we can do the debug. Actually, I don't want to debug, so I'll just comment that out. And so we've got a few definitions. This is the address of the motor driver that I'm using. Currently it's the default hexadecimal 30, which I don't know, is that 27 or something? I can't remember. And this is how many ticks. So as I was talking with about the encoder here. So this is our resolution here. So it's only 0.75 millimeters resolution. That's why it does. Well, you can see a millimeter, can't you? So you can see why it was doing this sort of staircase for the lines. And this is the resolution I was doing the circle in. So it's a number of points. I did 360. Really, I should have just made it go a bit quicker. We could have halved that probably. This is the speed. This is the delay for my ticks. So every time I send an I2C command, I wait 50 milliseconds. And these are details of my the size of my apparatus. So what we're going to do, I'll come to this sizes in a minute, and then work area height. So these are all dimensions of the physical dimension of my little plotter sort of thing. I've called it. What did I call it? I called it. I'll give it a name. Yeah. I was going to call it Tim's Trig Plotter. Yeah, let's call it. Let's put that there. So basically, yeah, it's all to do with trigonometry. Is this? Well, you've seen the plotter, so let's go down to. This is where my servo. This is just for the pulse width modulation on timer 1. That's what I've stuck the servo on. It creates a signal basically. So every time we change this value, it changes the position of the servo. and then draw by it. So I just, if we go down to here where we get the current position. So the way this works is we need to do some trigonometry, and what we are looking at basically is, oh, I've forgotten the name of that now. Where is it? Have I written it here? No. Well, it's this type of triangle. Basically, we've got two fixed points. So we've got where are we? There, A and C. A and C are my two pivot points, and B is the hinge where the pen is. So if you can imagine the pen being at B, and then the racks go down this line and down this line. So what we have to determine, we know the base, which is from A to, oh, actually, we know the distance from A to C because that's our fixed pivot points, and we know the length of our racks. So we know these 2 points, and so we can calculate the height. So this is how we do it. Oh, there we go. Saline triangle. That's what you call it. I can't remember names. Right. So it's a saline triangle. So where A is between the pivot points, and B is rack 1 and 2, and then S is this semi perimeter. Right. So if you can imagine a circle inside this triangle, that it's this edge, it's this edge, and it's this edge. Basically, that's what that is. And so this is the formula. So basically, we just work out that formula, and that determines the position. And basically, we use that to set the length of the racks. So I have a move to work area XY. What you've got to imagine is, let's just bring, right, so we have that, but let's do it better. Let's do that. So this is what we have. We have the 2 pivot points there, and then we have the what I call the hinge, which is where the pen is. If we look at this sketch here, we can see I've put all these dimensions in, and you can see what's going on. So we have this angle here, sorry, this radius. But what we can do is, as the pen moves, you can see, oh, this dotted bit there, and that bit there, that bit, and that bit. That's my work area. So that's the little square that I had drawn on the top. So as this moves, you can see what we're actually calculating. We have this one here, which is the height, and that gives us, we know the length of what we want here, which is actually from this point to this point, which creates us a right angle triangle basically, and that's what we do. Is we calculate this right angle triangle out and this right angle triangle out every time to calculate this and this length basically. So then we can work out how everything moves within this work area. Yeah, I think I've covered that. And the other stuff, like when we're drawing a circle, well, we draw a circle, what we do is we just do the normal XY, and then we convert that to to ractics, which we then, so we get a position, an XY here, then we move that to that point XY. So where are we? Yeah. So we've got our XY float. So to do that, what we do is calculate how many steps we need to do, and then we get the current racks from the target steps to the target ticks, shall I say, and then we move the rack that many ticks, and this is what we actually send to my motor driver over I2C. We just send it a code, so we send that GO code with the position of number of ticks at the speed, whatever speed I've set, and first one that goes to motor 1, and then the other one goes to motor 2. So then we just send that, and that there is what I can do is I can just preview here, there. So then we just send the commands. So we just use the this is the address, which is currently at 30. There's always this is an issue to do with the ESP 8266. It has an issue transmitting over I2C where the first piece of data is corrupted. So I always send a hash first, and my motor driver always starts from the second byte that it receives. So then I send the buffer, carriage return, and new line, then end transmission. So basically we send any byte that's going to get corrupted if we were sending it using an ESP8266. But we send it to the Arduino. Anyway, the first byte's ignored, but there should always be a first byte to be ignored by my motor driver. And then we send the buffer, which is this value here. And then we send a carriage return and transmission. And then my motor driver then takes over and moves the motor to that position. It's simple as that. The Arduino doesn't have to keep track of anything. It just sends go to command, and it goes. It's a bit like sending G code, and it does it. It's got its own processor and everything. So, anyways, I hope that was of some interest. I'll leave it at that. And thanks for watching.